Jensen Huang just explained how robotics is heading for major change. At Nvidia's recent GTC keynote, he outlined how Nvidia is shaping the future of robotics and why it's going to have a bigger impact than most people expect. In this video, I'll break down what's coming, what Nvidia is building, and why robotics is about to reshape everything. Stay with me. This will help you keep up with what's next in robotics and what you shouldn't miss. Let's get into it.
Let's talk about robots. Well, the time has come. The time has come for robots. Robots have the benefit of being able to interact with the physical world and do things that otherwise digital information cannot. We know very clearly that the world has severe shortage of human laborers, human workers. By the end of this decade, the world is going to be at least 50 million workers short. We'd be more than delighted to pay them each $50,000 to come to work. We're probably going to have to pay robots $50,000 a year to come to work. And so this is going to be a very, very large industry. There are all kinds of robotic systems. Your infrastructure will be robotic. Billions of cameras in warehouses and factories, 10, 20 million factories around the world. Every car is already a robot, as I mentioned earlier, and then now we're building general robots.
Jensen Huang made it clear. Physical AI and robotics are on track to become the biggest tech sector. And there are solid reasons behind that. If you haven't been following the numbers, this might surprise you. The global robotics market is projected to grow fast. From around $25 billion today to somewhere between $160 billion and $260 billion by 2030. That's a massive jump, and it shows how quickly this space is expanding. According to Citigroup analysts, the numbers go even further. They estimate there could be around 1.3 billion AI-powered robots by 2035, and that figure could reach 4 billion by 2050. That's a huge scale of growth in a short time. Even Elon Musk has predicted that the market for humanoid robots alone could eventually reach over 1 billion units per year, leading to a future where robots outnumber humans. So, what's driving this rapid growth? 3 key factors. Technology advances in AI have changed what robots can do. Machine intelligence, improved connectivity, and better control systems now allow robots to operate independently in complex, unpredictable environments. These aren't just digital tools. They're physical systems that can interact with the real world. Economics, aging populations in many Western countries, and tighter immigration policies are pushing the need for robotic labor. Robots offer a practical solution to labor shortages. On top of that, rising wages, even in countries like China, where factory worker pay has doubled since 2007, are making automation more financially attractive. Labor accounts for over 50% of global GDP. That alone shows the size of the opportunity. As the economics shift, replacing human labor with robots becomes a more viable option. The third factor is the range of applications, far wider than most people think. Manufacturing. Intelligent robots with advanced vision systems are improving production speed and quality control. Healthcare. Robotic systems can now assist in complex surgeries with a level of precision that wasn't possible before. Transport. Autonomous vehicles are changing how we move people and goods. Exploration and rescue. Robots can operate in dangerous environments where it's too risky for humans. Professional service robots are expected to dominate the sector in the years ahead. Their sales could more than double those of conventional and logistics robots, potentially reaching 170 billion euros by 2030. This shift shows how robotics is expanding far beyond traditional use cases. Robots are now taking on a wider range of roles across industries. At the core of this shift is what Nvidia calls physical AI, the integration of AI into real-world systems. It marks a transition from purely digital systems to intelligent physical machines. This isn't just about robots doing repetitive tasks anymore. It's about machines that can perceive, learn, and respond to their surroundings. Robots are evolving into autonomous systems capable of real-time decision-making and adaptation. As these technologies mature, they're set to reshape entire industries, open up new markets, and drive economic growth. So when Jensen Huang says robotics could become the largest sector, it's not just hype. It reflects real momentum. Now let's look at how Nvidia is pushing this forward with Project GR00T and Cosmos.
And robotics are moving so fast. Everybody pay attention to this space. This could very well likely be the largest industry of all. At its core, we have the same challenges. As I mentioned before, there are three that we focus on. They are rather systematic. One, how do you solve the data problem? How, where do you create the data necessary to train the AI? Two, what's the model architecture? And then three, what's the scaling laws? How can we scale either the data, the compute, or both so that we can make AIs smarter and smarter and smarter? How do we scale? And those fundamental problems exist in robotics as well. In robotics, we created a system called Omniverse. It's our operating system for physical AIs. You've heard me talk about Omniverse for a long time. We added two technologies to it. Today I'm going to show you two things. One of them is so that we could scale AI with generative capabilities. A generative model that understands the physical world. We call it Cosmos. Using Omniverse to condition Cosmos and using Cosmos to generate an infinite number of environments allows us to create data that is grounded, controlled by us, and yet be systematically infinite at the same time. Okay, so you see Omniverse, we use candy colors to give you an example of us controlling the robot in the scenario perfectly, and yet Cosmos can create all these virtual environments.